Hello. So, hello everyone, good morning. Good morning. So, this is lecture number 5 of vector analysis. So, if you haven't watched the previous 4 lectures, go through that. So, in this lecture, what we are going to do is we are going to see vector identities, right? So, there are 11 identities. So, we're going to prove all those 11 identities, right? Okay. So, as of now, we have defined what's meant by gradient, divergence, and curl. And then we have solved some problems based on that. If divergence is 0, then it is called a solenoidal vector. If the curl is 0, then the vector is called irrotational vector, right? So these are the important things that we have seen. And also we have seen what is meant by level surface. And for a level surface, we have found the equation of tangent plane and a normal line to the level surface, right? So these are the things that we have did so far, right? So we're going to start vector identities, right? Vector identities. So there are 11 identities. All these are very important, right? So in the next class, we will be completing this topic, gradient, divergence, and curl, and then we'll be moving on to the next topic, right? Okay. So vector identities. Right, vector identities. So there are 11 identities. So we're going to prove one by one. Before that, what we will do is we will just recall the definition of gradient, divergence, and curl, right? So we will recall all those definitions. So recall. If f is a scalar point function, if f is a scalar point function, if I think everything is visible, right? Okay. So if f is a scalar point function, then gradient of f, right? So gradient of f is defined as what is gradient? So it is dou by dou x of I vector, dou by dou y of j vector, dou by dou z of k vector into f. So which is dou f by dou x I vector, dou f by dou y j vector, dou f by dou z k vector, right? This is what we have already defined, right? Now this can be written as summation of dou f by dou x into I vector, right? Both are same. So what this summation says is, so you just running dou f by dou x into I. So next summation, if you sum this, this will be dou f by dou x I plus dou f by dou y j plus dou f by dou z k. Right? This is very important thing because for this only we are writing all the definitions again. So the del f is dou f by dou x I plus dou f by dou y j plus dou f by dou z k. This can also be written as summation of dou f by dou x into I vector. This is nothing but dou f by dou x I, that is you are running x and I, right? So y, j, z, k, both are same, right? Okay. Now second, if v is a vector point function, we can define divergence of v, right? So what is del dot v? Del dot v, right? Del dot v is, so del is dou by dou x of I vector, dou by dou y of j vector, dou by dou z of k vector, dot v, right? So dot v, and v is v1i plus v2j plus v3k. If you make a dot product, you will have dou v1 by dou x plus dou v2 by dou y plus dou v3 by dou z. That you already know, right? This can be written as summation of I dot, right? So this can be written as summation of I dot dou v by dou x, right? Both are same. Remember, here you gave your dot product, right? So I dot dou v by dou x, here we have normal multiplication. Both are same, right? Both are same. For example, what is v? V is a vector point function, right? Actually, this is this we will write this as dou v1 by dou x plus dou v2 by dou y plus dou v3 by dou z, right? If v is v1i plus v2j plus v3k. So if v is, so already we have seen, let us recollecting v2j plus v3k, then this can be written like this. both are same, right? Summation of I dot dou v by dou x. So dou by dou x of v, right? Dou by dou x of v, and you make a dot product with I, you will have v1, right? You will have v1. And similarly, next term will be j dot dou v by dou y. That is nothing but v2, right? Both are same. So divergence of v is same as summation I dot dou v by dou x, right? Okay. And again, if v is a vector point function, curl of f, right? This is divergence of v. This is gradient of v. Now, what is curl of v? This is del cross v. This is, you know, right? You know the formula ijk, determinant of ijk, dou by dou x, dou by dou y, dou by dou z. And this v vector component v1, v2, v3. So this can also be written as summation I cross dou v by dou x, right? So summation I cross dou v by dou x. So these are the three new things that we have learned now. So this can del f can, grade f can be written as like this, divergence of v can be written as like this, and the curl of v can be written as summation I cross dou v by dou x. So that means summation, you have to run this summation. The next term will be j cross dou v by dou y. Next term will be k cross dou v by dou z, right? So these three things are very important. So grade f, whenever you see summation dou f by dou x normal, right? This is normal multiplication. Whenever you see summation dou f by dou x I vector, you write grade f. Whenever you see I dot dou v by dou x, you write divergence of v. Whenever you see I cross dou v by dou x, you write that as curl of, right? And also you have to recall the vector properties, right? So the vector properties are the one that we come across in 11th and 12th standard. So I'm going to write those properties. The first property is a vector dot mb vector, right? So m is a scalar here. So a vector dot mb vector is same as ma vector dot b vector. And this is same as m into a dot b vector, right? And this is the very important. I'm going to write five properties. All these five properties are very important in order to prove vector identities, right? This is the formula we haven't started vector identities yet, right? Okay. Now second formula that we're going to use is a cross mb, right? Here we have dot, here we have cross. So a cross mb vector is same as ma vector cross b vector. This is same as m into a cross b vector, right? Now third formula is a dot b cross c. So a dot b cross c is same as a cross b dot c, right? A cross b dot c. Here there is only normal multiplication, but here we have dot, right? So a cross, here we have dot again. So a cross b dot c. And you know this property, right? A vector cross b cross c. Suppose if you want to shift c cross b, means you just have to multiply by minus, and you can shift. I'm just shifting this b cross c to c cross b by multiplying minus, right? This is basic property. Fourth property is a cross b cross c is same as a cross b cross c is same as a dot c into b vector minus a dot b into c vector. And the fifth and the last is a dot b into c vector, right? A dot b into c, sorry, this is normal c. A dot b into c vector is same as a dot c into b vector minus a cross b cross c, right? So you just have to by heart these five formulas in order to prove vector identities, right? So just recall, grade f is summation dou f by dou x I vector. Divergence of v is summation I dot dou v by dou x. Divergence curl of v is summation I cross dou v by dou x. And you just recall these five these 5 results based on vector analysis, right? Okay. Vector algebra that we come across in 11th and 12th, right? Okay. So we're going to start proving vector entities now. So first one that we're going to prove is so divergence of a plus b is same as divergence of a plus divergence of b, right? So that is we need to prove del dot a plus b, right? Del dot a plus b is del dot a plus del dot b because divergence of a is del dot a, right? So we'll prove this. This is the first identity. Now we know that what is del dot b? So it is summation I dot dou b by dou x, right? So instead of writing, I'm going to write these definitions from now on. I dot dou b by dou x. This can be done as summation I dot. Now we need to find del dot a plus b. So instead of b, I'm going to replace a plus b. This will be a plus b. This is summation I dot. So dou a by dou x plus dou b by dou x, right? Dou a by dou x, dou b by dou x. This will be summation I dot dou a by dou x plus summation I dot dou b by dou x. So what is this? This is del dot a, right? So because del dot b is summation I dot dou b by dou x, so instead of a we have a, and this is divergence of b, right? That's it. So we have proved divergence of a plus b is divergence of a plus divergence of b. This is the first identity, right? Therefore divergence of a plus b is divergence of a plus divergence of b. So we move on to second entity. Curl of a plus b is equal to curl a plus curl b. That is del cross a plus b is del cross a plus del cross b, right? Curl a, curl b, curl of a plus b. So we'll prove this. So we know that what is del cross b? Summation I vector cross dou b by dou x. Now this implies what about del cross a plus b? So replace this I by a plus b. This will be summation I vector cross dou a by dou x, dou b by dou x. This will be summation I cross dou a by dou x plus summation I cross dou b by dou x. This is nothing but curl of a. This is nothing but curl of b, right? So therefore curl of a plus b is equal to curl a plus curl b. Is it clear? Is as of now we have seen two identities. First identity is divergence of a plus b is div a plus div b, and curl of a plus b is curl a plus curl b, right? Now we'll move on to third identity. If A is a differentiable vector point function, and phi is a differentiable scalar point function, and phi is a differentiable scalar point function, then divergence of phi a, right? So this phi is scalar point function. For example, phi can be x, y, z. It can be x plus y plus z, right? And a is a vector point function. For example, a can be 2x plus 2x I vector plus x square j vector plus y square k vector, right? Like that. So divergence of phi a will be gradient of phi dot a plus phi into divergence of A, right? So plus phi into divergence of A. This is what the third entity is. This is same as divergence of A. So del dot phi A. So we need to prove del dot phi A is grade phi dot A plus phi into divergence of A. This is what we need to prove now, right? So for proving this, I'm going to use the result that A dot MB vector, right? A dot MB vector is same as MA dot B vector, right? MA dot B vector, MA dot B vector, and this is same as M into A dot B, right? MA dot B, MA vector dot B vector, right? So you just have to remember, right? So whenever we see this, we have to use this result. A dot MB is same as MA dot B. We're going to use this result in this proof. I'll let you know, right? So proof. So we need to prove this, right? Divergence of phi A. Okay. Now we know that what is divergence of B? It is summation I dot dou V by dou X, right? I dot dou V by dou X. Now what about divergence of phi A? This will be summation I dot dou by dou X of phi A, right? Dou by dou X of phi A. This will be summation I dot. So differentiate this. So I'm going to use UV method because both are functions of x, y, z only. So dou phi by dou X into A plus dou phi by dou X into A plus phi into dou A by dou X plus phi into dou A by dou X, right? This is same as summation I dot dou phi by dou X dou phi by dou X into A plus summation I dot phi into dou A by dou X, right? Okay. Now I'm just going to use the property here. So you can see A dot MB vector. You remember I is a vector, A is a vector because A is a vector point function, and you can treat P as a scalar because P is a scalar point function. So derivative will be scalar also, right? So A dot MB, and here also A dot MB, right? A dot MB vector, A dot MB vector. Now here I'm going to make use of this, and here I'm going to make use of this, right? Because A dot MB is same as MA dot B, and that is same as M into A dot B. So here I'm going to use this, and here I'm going to use this, right? So this will be summation. So MA dot B. So MA dot B. So what is MA? So the normal multiplication, right? M into A. So M into A dot B, right? Dot B plus summation. Here I'm going to make use of this result. So M into A dot B. M into A dot B, right? Now, what is this? What is this? This is nothing but grade phi, right? Summation dou phi by dou X, summation dou F by dou X into normal multiplication of I will be grade F, right? So this is same as gradient of phi, right? And this is same as gradient of phi dot A. And if I take this phi outside, we will have summation I dot dou A by dou X. What is this? This is divergence of phi, right? Therefore, this will be equal to grade phi dot A. This phi is I can take this phi outside because phi is scalar. So I dot dou A by dou X is divergence of A. This is what we need to prove, right? So divergence of phi A is grade phi dot A plus phi into gradient of A. Very simple, right? So whenever you see this, you make use of this result. A dot MB is MA dot B, that is same as M into A dot B. Okay. Fourth, again the same thing, right? A is a differentiable vector point function, and this phi is a differentiable scalar point function. Now here we have proved divergence of phi A. Now we are going to prove curl of phi A. What about curl of VA? Curl of VA, right? So curl of VA is grade phi cross A, grade phi cross A plus phi into curl of A. So same here, instead of grade phi dot, instead of dot we have cross here. That's it. Here we have dot, here we have cross, and here we have curl A, here we have divergence of A. That is the only thing, right? Difference. Okay, that is we need to prove. That is we need to prove curl of phi A is grade phi cross A plus phi into curl of A. This is what we need to prove, right? Yes. So for this, I'm going to make use of A cross MB vector is same as MA vector cross B vector, and that is same as M into A cross B vector, right? For previous, we have used this result, right? Okay. So we'll start. So what about, we know that what is del cross B? Del cross B is I cross dou V by dou X, right? Here we are using del dot V, that means we need to put dot here. For cross, we need to put cross. So that this implies, what about del cross phi A? This will be summation I cross dou by dou X of phi A. This will be summation I cross dou phi by dou X into A plus phi into dou A by dou X. This can be done as summation I cross dou phi by dou X into A plus summation I cross phi into dou A by dou X, right? So again, similarly, you can see A cross MB vector, A cross MB vector. So here I'm going to make use of this result, and here I'm going to make use of this result. So this will be MA cross B, summation M into A. So dou phi by dou X into I. So MA cross B. So here B is A. Plus here I'm going to make use of M into A cross B. So phi into A cross B. So if you know this result, then problem is very easy. Now what is this? This is grade phi. Grade phi cross A. And if I take this phi outside, this will be summation I cross dou A by dou X. This curl A. So grade phi cross A plus phi into curl A. This is what we need to prove, right? Grade phi cross A plus phi into curl of A. Right? Is it clear? So all these four entities are very easy. The only thing is you have to make use of, you have to remember A dot MB is MA dot B. That is same as M into A dot B. And curl of A is A. You have to use this result. Okay. So we move on to the fifth entity. So fifth entity is divergence of A cross B. Divergence of A cross B, right? We already proved divergence of A plus B is div A plus div B, but here we have A cross B. B dot curl A minus A dot curl B minus A dot curl B. So this is what the next identity is. I'll just check this once again. Yes. Fifth entity is divergence of A cross B is B dot curl A minus A dot curl B. Okay. So for this, I'm going to use this result. So we are using these three results, right? So A dot B cross C is same as A cross B dot C. So A dot B cross C A dot B cross C is same as A cross B dot C, and whenever you need to shift B and C, you need to multiply by minus. That you know. Solution. Or this is same as divergence of A cross B is B into curl of A minus A into curl of B. This is what we need to prove, right? Now, what is divergence? Sorry, what is divergence of A cross B? We know what is divergence of B. It is summation I dot dou B by dou X, right? So that means, what about divergence of? This implies divergence of A cross B will be summation I dot dou by dou X of A cross B. This is summation I dot dou A by dou X cross B plus B into dou A by dou X cross B plus A into dou B by dou X, right? UV method. A cross dou B by dou X. This is summation I dot dou A by dou X cross B plus summation I dot A cross dou B by dou X, right? A cross dou B by dou X. Now what I'm going to do is we need minus here, right? We need minus here. What I'll do is, let us keep this as it is, I cross dou A by dou X cross B. I'm just putting minus here, and I'm shifting dou B by dou X cross A, right? I'm just interchanging these two, and I'm putting minus here. Now can I use the property A dot B cross C, right? A dot B cross C, A dot B cross C. B and C both are vectors here, because B is here, A and B both are vector point function. Here A and B both are vector point function. So A dot B cross C, right? A dot B cross C. Now I'm going to use the result A cross B dot C. So A cross B dot C. A cross B dot C, and here A cross B dot C, right? Here C is A. So what is this? This is curl of A, right? Curl A dot B, and what is this? This is curl B dot A, and A dot B is same as B dot A. So this is same as B dot curl A minus A dot curl B, right? A dot B is same as B dot A. Is it clear? So that is what I am saying. To understand, if you know these properties, A dot B cross C is A cross B dot C, then the problem is very easy, right? The problem is very easy. Okay. So sixth entity is we have proved divergence of A cross B. Sixth is curl of A cross B. Curl of A cross B. You can see we are doing same thing, right? So we are applying phi. Here we have A plus B. We have taken A plus B. We have applied divergence and curl to that. So we have finished first two, and we have taken phi A. Phi is scalar point function. A is vector point function. We have applied divergence to it, and we have applied curl to it. So another two is over. Now we are taking A cross B, and for A cross B, we are up here. A and B both are vector point function, right? We are taking A cross B, and I'm applying divergence to it and curl to it. So now I'm going to apply curl to it. So curl of A cross B is B dot del into A minus B into divergence of A minus A dot del into B. You don't about this thing, right? So you just proceed, you'll get this A into divergence of B, right? This is what we need to prove. So curl of for vector analysis, Krishna series is the prescribed textbook. I have given the textbook in Telegram group, right? If you can download there. So curl of A plus B is B dot del into A minus B div A minus A dot del B plus A div B. Okay, so we prove this. Okay, so what is curl of the summation I cross dou V by dou X? So that means what about curl of A cross B? This is summation I cross dou by dou X of A cross B. This is summation I cross dou A by dou X cross B plus A into dou B by dou X. So this is summation I cross dou A by dou X cross B plus summation I cross A into dou B by dou X, right? A into dou B by dou X. A into dou B by dou X. Okay. Now A cross B cross C. So I'm going to make use of the result A cross B cross C. What is A cross B cross C? Already written, right? A cross B cross C is so A dot C into B, A dot C into B minus A dot B into C, right? Okay, here we have cross, right? Okay. Okay. So I'm going to make use of result now. A cross B cross C is A dot C into B minus A dot B into C. So A cross B cross C, and here also A cross B cross C, right? A cross B cross C. Okay. So this is summation. So A dot C. So A dot C into B minus A dot B into C, right? This is the expansion of this summation we have for all. Plus here I'm going to apply the same result here. So A dot C into B minus A dot B into C. Right, into C. Now we just simplify this. So we have I dot B. Okay. So we have I think we have arrived, right? So these are the 4 things we need to prove. These are the 4 things they are, right? Okay, so I'll just change here. I'll just change the order here. This is same as summation summation I dot dou b by dou x into A minus summation A dot I dou b by dou x, right? A dot I is same as I dot A. I'm just saying the order. I'm writing this as first term, second term, third term, fourth term, plus summation B dot I dou A by dou x minus summation I dot dou A by dou x into B, right? What is I dot dou B by dou x, right? What is I dot dou B by dou x? This is nothing but divergence of B, right? This is nothing but divergence of B into A minus divergence of B into A. And what about A dot I dou B by dou x, right? What about A dot I dou B by dou x, right? Now remember, whenever you have a vector AB, you don't need to write that in summation, right? So you always take that A outside, I into dou by dou x of B, right? So here also, if you have noticed, I would have taken this B, I would have not run this B summation here, right? And even though the summation is for whole, I'm not running this for B. So don't break summation for a vector, right? Because it is already a vector. So here you don't need to run summation for A and B. And this is again this can be written as B into summation I dou by dou x A, right? Minus A we have dot, right? Summation A dot dou A by dou x into B. This divergence of A, right? This is divergence of A into B. Okay. Right? Whenever you have like this, whenever you have A dot I to something, you just take this AB outside and run the summation only for, you just take AB to be any vector and verify this both will be same, right? And again you can see whenever you have something like this, you just take this B and A outside, right? Okay. Now this is divergence of B into A minus A into divergence of B, right? A into, here you have dot, right? Here we have dot. Also we have to. Okay. This is divergence of A into B, right? This is divergence of A into B. So we have arrived at these two, right? So this is nothing but A dot. This is nothing but gradient, right? This is nothing but gradient because I dou by dou x plus j dou by dou y plus I dou by dou x plus I plus j dou by dou y is nothing but gradient, right? A dot del into B plus again here this gradient again minus divergence of A into B. What we need to prove, right? So I repeat. So why you take, see, these are the normal properties that you can verify, right? You just take A to be, some vector, right? Let us take A to be some xi vector plus yj vector. Let us take B to be x square I vector, right? Because A and B are two vectors. Now you find A dot I dou B by dou x. Now you find A dot I dou B by dou x plus A dot J dou B by dou y, right? I just take A to be two-dimensional vector. So what about a dot I dou b by dou x, a dot j dou b by dou y? So what about a dot I? So a dot I we will have only x. What is dou b by dou x? It is 2x I vector. What about a dot j? A dot j you will have only y, and dou b by dou y will be 0. So here we will have 2x square I vector, right? Now similarly you find a dot. Similarly you find a dot del into phi. Now similarly you find this LHS part. Now similarly you find a dot summation of I into summation of I dou by dou x is same as I into dou by dou x j into dou by dou y into b, right? Now what about a dot I into dou by dou x, I into dou by dou x of b, right? Dou b I into dou b by dou x. So dou b by dou x. So dou by dou x 2x, and this will be 0, right? So you will have only this. And what is a? A is xi plus yj. So if you put a to be xi plus yj, and if you make a dot product here, so a dot so this is 2x, and what about a dot del into b, right? Okay, first we need to find a dot del and then we need to find b. Okay, so you just apply a dot del into b. You will get again both. If you make a dot product with a again, you will get again this 2x square I, right? 2x square I. That is, you just make use of you just make it write it clearly. Okay, so whenever you find summation sum a dot I into dou b by dou x, right? You make it as result, right? This is same as a dot summation I dou by dou x into b, right? This is nothing but del operator. So a dot del into b. So whenever you see this, right? So whenever you have a dot I into some dou b by dou x, so you just write a I dou b by dou x into b, right? Both will be same. You just take a b to be some vector and you verify both will be same only, right? So here also again you can see b dot I. So b dot dou I dou by dou x into a. So it will be b into grade b into del b into del into a, right? So b dot del into a. Is it clear? So I'll repeat once more. So we need to prove curl of a cross b is b dot del into a minus b div a minus a dot del b plus a div b, right? You just make this note, right? Okay. Or else I can also add it here so that you will not forget. So summation I cross summation a dot I dou b by dou x, a dot I dou b by dou x. This is same as summation a dot this same as a dot dou by dou x of I into b. This is nothing but a dot del into b, right? Remember this, right? Remember this so that you won't forget. Okay. I applied this result, right? Note 6. So I applied note 6 to both here. Then the remaining is very easy, right? So a cross I cross dou a by dou x cross b plus I cross a cross dou b by dou x. So a cross b cross is A dot B into C minus A dot B into A. After that, very easy, right? I dot B, I have just interchanged these four, right? So this is first term, second term, third term, fourth term. Now I've written this as 3, 4, 1, 2, right? So I'm just interchanging the term. This is nothing but dive B, this is nothing but dive A. Here I applied node 6 to both. Move on to seventh property. So prove that grade of A dot B is equal to B dot del into A plus A dot del into B plus B cross curl A plus A cross curl B, right? This is what we need to prove. So we'll prove this. So what is, we need to find gradient. Remember, grade of A dot B, right? Okay. Now what about gradient of F? It is summation dou F by dou X into I vector, right? So then you don't put dot or cross here. It is nothing but a gradient. Now what about gradient of A dot B? It is summation dou by dou X of. So instead of F, I'm going to put this as I vector into, instead of F, I'm going to put A dot B. This is I into dou A by A dot dou B by dou X. So I'll just apply UV method. So A dot dou B by dou X, then we have dot plus B dot or dou A by dou X dot B, right? So this is summation I into A dot dou B by dou X plus summation I into dou A by dou X dot B, right? Now here I'm going to make use of the property that A dot B into C. A dot B into C. I've written here, right? A dot B into C. This is A dot C into B. This is A dot C into B minus A cross B cross C, right? Minus A cross B cross C, right? So A dot B into C. This is same as summation A dot dou B by dou X into I plus dou A by dou X dot B into I, right? So again, I'm going to make use of this property now. So A dot B into C, right? A dot B into C. So first we will apply for here and then we will apply for here. And let us call this as some I1. Let us call this as some I2, right? So we will do separately, right? Because we will have long term. So what is I1? So I1 is summation A dot dou B by dou X into I vector, right? So what is A dot B into C? It is A dot C into B minus A cross B cross C, right? A cross B cross C. A dot C into B. Okay. Now we will apply this. So A dot B into C, right? Okay. So this will be A dot C. A dot C. So A dot C into B, right? Into B minus A cross B cross C, right? Yes. This is again summation A dot I, summation A dot I I can use a node 6, right? This is a dot I into dou by dou x into b, right? A dot I dou b by dou x. So this is same as a dot summation of this, right? This is summation a cross dou b by dou x cross I. Now this is this I can write this as a dot del into b, right? We already written a node 6, right? A dot del into b. Now we need to simplify this, right? We need to simplify this. Minus summation. We have a cross dou b by dou x cross I, right? We have a cross dou b by dou x cross I. Okay. I think I can take this a outside, right? So summation a, or you can also use the property a cross b cross c. So a cross b cross c, you can also use the property also. So a cross dou b by dou x cross I, right? A cross this I can write this as a cross summation dou b by dou x cross I. This is a dot del into b minus a cross this is curl b, right? So I think I put first part. Yes. So a dot del into b minus a cross curl b. So you can see we have proved the first part, right? Okay, we have minus, right? A cross curl b. Okay, so for I cross dou by dou x is curl, right? I cross. So let us put this plus and we will shift this to I cross dou b by dou x. Because definition is I cross dou b by dou x, right? So the taken minus outside, this minus minus will be plus. So now I can write this as plus a cross b. So we have arrived at these two, right? Now similarly you find I2. So for I2 you will get this, right? So similarly you find I2. So you'll get I2 to be b dot del into a plus b cross curl a, right? So you add I1 plus I2. So you will do the required thing, right? You do required thing. Very simple. You apply the definition, you will get these four parts, right? Okay. So we want the eighth. So prove that divergence of grade phi is equal to 0. It's equal to del square phi, right? Del square phi. So whenever you see phi, you think that as a scalar point function, right? So we need to find divergence of grade phi and it's equal to del square phi. Okay. Now what is divergence of phi? So it will be del dot p. It will be del dot b, right? Del dot b, which is nothing but dou by dou x of b1, dou by dou x of b2 plus dou by dou x of b3, right? That is p is equal to b1i plus b2j plus b3k, right? We know this. Now we need to find divergence of grade phi, right? Now divergence of what is grade phi? So it is dou phi by dou x I vector, dou phi by dou y j vector, dou phi by dou z k vector. Now what about divergence of this? This is del dot this, right? Del dot dou phi by dou x I vector, dou phi by dou y j vector, dou phi by dou z k vector. Very simple, right? Divergence of B is del dot B. So divergence of something is del dot something. So what is divergence? What is del? It is dou by dou x of I vector, dou by dou y of j vector, dou by dou z of k vector, dot dou phi by dou x I vector, dou phi by dou y j vector, dou phi by dou z k vector. Now make a dot product here. So this will be dou by dou x of dou phi by dou x, dou by dou y of dou phi by dou y, dou by dou z of dou phi by dou z. This is nothing but dou square phi by dou x square, dou square phi by dou y square, dou square phi by dou z square. So if I take this phi outside, it is nothing but del square phi, right? It is nothing but del square phi. So del square, del means dou by dou x of phi plus I into dou by dou y. But if you make a dot product with the del dot del, you will get this, right? So del square phi. This is nothing but del square phi. Dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square, right? So we move on to ninth. Move on to ninth. Prove that the curl of the gradient, curl of the gradient of phi is 0. That is, we need to prove curl of the gradient of phi is 0, right? So del cross del phi. So we need to prove del cross del phi is 0, right? So we'll prove this. So what is del phi? Del phi is dou phi by dou x into I vector, dou phi by dou y into j vector plus dou phi by dou z into k vector. Now we need to find del cross del phi. So this will be determinant of I vector, j vector, k vector. So del is dou by dou x, dou by dou y, dou by dou z. Now del phi is dou phi by dou x, dou phi by dou y, dou phi by dou z. So expand this. It will be I vector into, so dou by dou y of dou phi by dou z. This is nothing but dou square phi by dou y dou z minus dou square phi by dou z dou y minus j vector into dou by dou x. So dou square phi by dou x dou z minus dou square phi by dou z dou x plus k into dou square phi by dou x dou y minus dou square phi by dou y dou x, right? Okay. Now y z z y. Okay. Now you can see if this phi is a scalar point function, right? If we already discussed in calculus, if this phi possesses continuous second order partial derivative, if this phi possesses continuous second order partial derivative, then dou square p by dou x dou y is same as dou square p by dou y dou x, right? And similarly, dou square p by dou x dou y, so dou x dou y is same as dou y dou x, and dou square p by dou y dou z is same as dou square p by dou z dou y. Dou square p by dou z dou x is same as dou square p by dou x dou z, right? Now, if we will assume that this process, actually the question is redundant, they have to prove, they have to tell that this p has continuous second order partial derivative. If this happens, then these two will be equal. So in that case, you will have I into 0, j into 0 plus k into 0, which is always 0, right? So you assume that p has, um, yes. So if it possesses, again, if it possesses, because it is not always true that dou square phi by dou y dou z is all, it is not always true. These two are right. We already covered partial derivative in calculus. There I have mentioned, right. So if this has continuous second order partial derivative, then these two will be equal. In that case only it will be 0, right? Okay. So move on to 10. Prove that divergence of curl A is equal to 0, right? That is divergence. So del cross A is 0, right? So let us take A to be A1 I vector plus A2 J vector plus A3 K vector. Now you find a del cross A, right? Now what up del cross A? Okay, now first we'll find del cross A. Del cross A will be I J K dou by dou x, dou by dou y, dou by dou z, A1, A2, A3. Again, this will be I into dou A3 by dou y minus dou A2 by dou z minus j into dou A3 by dou x minus dou A1 by dou z plus k into dou A2 by dou x minus dou A1 by dou y. Now what about del cross A? So del cross A. So you just have to differentiate, right? So though I'll use directly, so you just have to del dot A. So make a dot product with this. So del is dou by dou x. Dou by dou x of I vector dot this. So we'll be having dou by dou x of dou A3 by dou y minus dou A2 by dou z minus dou by dou y of, see, I'm just using the definition, that's it, right? Minus dou by dou y of dou A3 by dou x minus dou A1 by dou z plus dou by dou z of dou A2 by dou x minus dou A1 by dou y. Right? I'm just making a dot. What is the definition of del dot V? Dou V1 by dou x plus dou V1 by dou y plus dou V2 by dou z. Here V1, V2, V3 are, this is V1, this is V2, this is V3, right? Okay. So we just differentiate this with respect to, now you can see again if this has continuous second order partial derivative, then again all this will get cancelled, right? All this will get cancelled. So this will be dou square A3 divided by dou x dou y minus dou square A2 divided by dou x dou z minus dou square A3 by dou y dou x plus dou square A1 by dou y dou z plus dou square A2 by dou z dou x dou square A1 by dou z dou y. Can see these two will get cancelled. with the assumption that it has continuous second order partial derivative, right? Assuming that A has continuous second order partial derivative. Again, dou square a2 by dou z dou x, this will get cancelled. So we will get this to be equal to 0, right? So 11th, last one, you take an exercise, right? You take an exercise, you prove this very easily. So prove that del cross A is equal to del into del dot A minus del square A. So del square A is nothing but dou square A by dou x square, dou square A by dou y square, dou square A by dou z square, right? So this is what we need to prove. You take exercise. I'll give you some int. Let us take A to be equal to A1 I vector, A2 j vector plus A3 k vector. Or else you find LHS RHS separately, right? You find del cross A, after that you find del cross A. Now you find del dot A and then you make del into this, you will get both to be equal, right? Take that exercise. So if you have any doubt in this, text in Telegram, I'll send the solution for this, right? Very simple, you just try this, right? You get both to be equal. So in this class, what we have did is we have finished the 11 identities based on division curve. So next class we're going to touch up some more problems on this, and then we're going to wind up this topic, which is gradient, divergence, and curve. After that, we'll be moving on to the next topic, right? So if you have any doubt, you can ask, or else we'll wind up. Okay, thank you. We'll see you next class. Thank you.